What's going on YouTube? Welcome to my another video in which I'm going to be continuing with my with the previous challenges of object-oriented programming for JavaScript. So without further ado, let's get started. So this one's about understanding. Uh, sorry, what I meant was understand where an object's prototype comes from. So hopefully you've all understood the concept of prototypes from my previous video. If you haven't, mm, please comment on my video, so I'll probably be making a separate video in regards to the concept of prototypes. Okay, I mean the object's prototype. Okay, cool. So in this one it says just just like people inherit genes from their parents, an object inherits its prototype directly from the constructor function that created it. For example, here the bird constructor creates the duck object. Yep, so that's the bird constructor, and it's taking in the property name and then assigning the passed in value of name, which is Donald, to this property's name, which is the bird's name, and the duck is the instance of the bird. Okay, so duck inherits its prototype from the bird pro, from the bird constructor function. You can show this relationship with the is prototype of method. So bird prototype is prototype of the duck. Okay, that's interesting. So you choose is prototype of to check the prototype of beagle. Okay, so basically what it's saying is that the bird, in the simplest form of explanation, which is parents and objects, the bird is a parent for duck, and the duck is the child of the parent. So the duck will inherit all the prototypes that are of the bird in this way, right? And we can also show the behavior of the statement that the dog inherits his prototype from the bird constructor function, choosing the is prototype of. So bird prototype is prototype, and then the actual child, right? Or the object. So this is going to return true. So now we need to check use is prototype of to check the prototype of beagle. So we need to check the prototype of beagle. So what we're gonna do is give it choose the parent object, which is this one, the constructor function. So parent, and then prototype, and then we need to check if beagle is the beagle inherits all the prototype of dog. So we would do is prototype, and then the instance of name, which is the beagle object. Beagle object. Alright. So if you're still not understanding, the way I like to see it, that this is a parent class or an object, and this the instances of are the child. So the child is inheriting the main object, which is this one. This is just my perspective of seeing this. All right. So let's check if you pass the test. Nope, we haven't passed the test. Is not. Oh, my bad. I forgot to put the is prototype off. All right, that's the proper keyword. Not is this prototype. Cool. So let's now check. Yay, we're passed it. Well done, guys. Let's move into the next one. Right, cool. So in this one, it's saying that understand the prototype chain. Cool. So all objects in JavaScript, with few exceptions, have a prototype. Yep, all objects. Cool. Also, an object's prototype itself is an object. Yeah, okay. So it takes a constructor here and then type of bird dot prototype. So it's finding the type of what's the type of this the bird's prototype. Okay, so because a prototype is an object, a prototype can have its own prototype. Yep, because it's an object. In this case, the prototype of bird prototype is object dot prototype. Cool. So object prototype is prototype of bird dot prototype returns true. Why? Because the bird prototype is from the object's prototype. Cool. So how is this useful? You may recall the has-on property method from a previous challenge. Yep, has-on property of a previous challenge. Yep. So let doc is new bird. Okay. Yep. It's creating an instance of a bird which is a duck, and then it's checking that if the duck has its own property called a name, which will return true because bird has it, and bird isn't, and the duck is an instance of a bird. I really hope it makes sense, guys. Now, so anyway, let's move on. The has-on property method is defined in object's property. Prototype. Sorry about that. Which can be accessed by bird.prototype, which can then be accessed by duck. Okay, this is an example of a prototype chain. Alright, cool. So in this prototype chain, bird is a super type for the duck, while duck is a subtype, and object is a super type for both bird and duck. So it's essentially what it says that object is a parent, okay, and then the bird is a child of the object, and then duck is the child of the bird. All right, so parent child of the parent, and then child of the child of the parent, if that makes sense. Cool. So object is a super type for all objects in JavaScript. Therefore, and any object can use the has-on property method. modify the code to show the correct prototype chain. Okay, cool. So now we need to modify the code to show the prototype chain. So like we said, that dog is a prototype of the object. Alright, so here what we're gonna do is object dot prototype, and this prototype of that returns true. Fix the code below to say that if it values to true. Yep, let's test this one if that works. Yes, perfect. So essentially what it said is that because dog is already a I mean beagle is a child of dog, and then we had to specify here that dog is a child of the object, and overall object is a parent for both these um, prototypes. Okay, alright, so let's move on to the next challenge. Bodacious. Oh yes, I don't even know what that means. Anyway, uh, this one's about use in inheritance so you don't repeat yourself. Oh, I love inheritance. There's a principle in programming called don't repeat yourself, which is called DRY. Yes, a very common known principle. Do not repeat yourself. Hang on, I just disobeyed that. I repeated myself. I'm a really bad man. Anyway, uh, the reason repeated code is a problem. And the reason repeated code is a problem is because any change requires fixing code in multiple places. This usually means more work for programmers and more room for errors. Notice in the example below that the describe method is shared by bird and the dog. So there's a bird prototype. Yep. So constructor is bird. Yep. It, it invokes the main constructor, and then it describes, it inserts the property of describe as a function, and then logs my name is, yep, this dot name, perfect. And dog property, constructor is dog and describe, and it uses the same describe function here as well. So essentially what is pointing out there, the describe function has been used multiple times. Right, the describe method is repeated in two places, which means that we are repeating ourselves. The code can be edited to follow the drive principle by creating a supertype or parent called animal. Right, so animal, yep, and then animal, perfect. So since animal includes the describe method, you can remove it from bird and dog. Cool. Yep. So the bird yeah, I've read that one already. So the bird prototype is this one. Yep. It contains the constructor of the bird. Yep. And then the dog prototype, also okay. So what is done is removes the describe method from both the prototypes. Okay, that makes sense. The eat method is repeated in both cat and bear. Edit this one and cat and bear. Ah, this one. Right. The The eat method is repeated in both cat and bear. Edit the code in spirit of the try by moving the eat method to the animal super type. So that's the animal super type, and is already declared a prototype here. So all we need to do is declare include the eat method in the super type, which will that mean that we don't have to uh, declare eat in two places. We can just use one. Alright, and I'll just copy and paste this line here, which outputs the words in the string in console. Alright, cool. So if we wanna just remove this eat method and this eat method. Alright, there we go. Perfect. So now because animal is a super type and both bear and 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 um and cat are inheriting it, it will use the same e function. Alright, let's check if we did it right. Yay, brilliant. Bullseye. Let's move to the next challenge. Right, cool. So this one's about inherit behaviors from a super type. In the previous challenge, you create a super type called animal that define behaviors shared by all animals. Yep, that was super type there, and that was its prototype. Cool. Right, so yep, that's the one. Perfect. So it's creating an animal constructor and then one object you can say as well. And then it gave the eat method to the prototype of the animal and then give it this method. Alright, cool. So this and the next challenge will cover how to reuse animals methods inside bird and dog without defining them again. Oh, that's a pretty useful technique. It uses a technique called inheritance. This challenge covers the first step. Make an instance of a super type or parent. Yep. You already know one way to create an instance of animal using the new operator. Yep. There are some disadvantages when using this syntax for inheritance, which are too complex for the scope of this challenge. Instead, here's an alternative approach without those disadvantages. Right. So object.create object creates a new object and sets the object as the new object prototype. Okay, this one. So in this case, object.create whatever's in the brackets, that will be the the child class of the parent. Okay, the new object's prototype. Cool. So recall that the prototype is is like the recipe for creating an object. By setting the prototype of animals to animals prototype, you you're effectively giving the animal instance the name, the same recipe as any other instance of the animal. So animal.eat prints that one. Animal is an instance of an animal, returns true. Yep, that's correct. So now it says they or use object dot create to make two instances of animal named duck and beagle. Right, so let's get down to the code. So now we need to make two instances of animal prototype named duck and beagle. And how do we do this? By assigning this instance new object dot new no object dot create. So we're creating an animals prototype and assigning it to the duck, so that all the properties of animals can be used in the duck. All right. So animal prototype. Perfect. And this one the same as that as well. Object dot create animal dot prototype. Perfect. Alright, so now because my duck and beagle, first of all I'll make the code a bit more readable. Yep, now. So because the duck and beagle inherit from my animals object prototype, which is this one here. Now, whatever I type in the constructor here, dog will have access to that as well, and it will also have it will also have access to the methods defined in the animals prototype. Okay, so essentially these two are my child classes and this is my parent class. All right, cool. So it does print out the method, which is nom 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 nom, yeah. Which is apparently how animals eat. Yep. Anyway, I really, I really hope you are understanding the inheritance concept quite well. If you don't, you can always comment and ask me questions, and I will make sure I answer every single one of you. All right. So that being said, let's get to the next challenge. Terminated. Oh yeah, we are killing it. Right. So now this one's about set the child's prototype to an instance of the parent. So now I think we're gonna do the opposite. In the previous challenge, you saw the first step for inheriting behavior from a supertype. Yep, or parent, animal, making a new instance of animal. This challenge covers the next step. Set the prototype of the subtype or a child, in this case a bird, to be an instance of the animal. So before we did the parents, the child inheriting from the parents, and now we're gonna do the opposite. So we're gonna set the child's prototype to be an instance of the parent. Alright, so let's see how to do that. So bird prototype is assigned to create a new prototype, which is animal. Yep, and then remember that the prototype is like the recipe for creating an object. In a way, the recipe of bird now includes all the key ingredients from animal. Yep. Okay. So that duck is assigned to a new bird, Donald, and then duck eat, eat uh, and then the duck calls the bird's method to, to print out how the duck eats. So the duck inherits all of the animal's properties, including the eat method. Yep. Modify the code so that instance of the dog, which is this one, inherit from the animal. So instance of the dog inherit from the animal, which is this one there. Right. Alright, cool. So it says that modify the code so that instances of dog inherits from animal. So the dog in so the instance of dog, which is beagle, inherits from animal, which is animal hair. Cool. Oh, hair. Cool. So what we can do is we can do, say, the the prototype has to inherit from the animal's instance. Okay. No, sorry. I think I'm being a bit confused now. So we need to set the uh, dog's prototype to the instance of the animal. All right, like it says here, set the child's prototype, which in our case will be called the dog's prototype, to an instance of the parent, which is this one. Alright, so we'll start by creating the dog's prototype, dog prototype, and then assign assignment operator, and then keyword new, and then a dog. Alright, no, sorry, my bad, animal. Alright, so that would be like whatever's in the animal's object. Okay, that's gonna be all assigned to the dog's prototype, because here we had to create the dog's prototype by ourselves. All right, and uh, this test will pass because it's already printing on nom nom nom. But if you want to use another syntax to create, I mean, another syntax to replace the new keyword here, you can do as object dot create, and then the prototype there, which is animal dot prototype. There we go, perfect. So this syntax and then the previous syntax that I showed you, they are the same. Alright. However, the new keyword does have some disadvantages. However, I don't know that at the moment, but Free Code Camp is gonna hopefully teach us those differences or tell us in the coming challenges. Alright, so do this, and personally I like to use a new keyword. it's easier and it's more readable. Alright, but you can choose both. So I'll just put the other syntax as a comment. So if you guys want to choose that one, you guys are more than welcome to do so. Alright, animal, there we go, prototype, perfect. And I'll just comment this out so that it doesn't fail the test. Perfect, there we go. So now let's run the test, and yay, we passed it. Brilliant. Let's go on to the next challenge. Okay, this one's about reset and inherited constructor property. Okay, so now we're going to be resetting the inherited constructor properties. When an object inherits its prototype from another object, yep, it also inherits the supertype's constructor properties. Right, here's an example. And there's a bird object, and these are the properties. So the bird, the animal's prototype is assigned to the bird's prototype. So parent, child class. All right. So now the dog is a new instance of the bird. Right, and the dog gets the constructor of of the dog of the bird, because it's the instance of a bird, which in this case is function animal. Perfect. But the dog, cat, and all instances of bird should show that they were constructed by bird and not animal. Yep, that makes sense. Yep, perfect. To do so, you can manually set the bird's constructor property to the bird object. Right. I don't really understand that. Let's have a read again. But the duck and all instances of the bird, which is this line here, should show that they were constructed by bird and no animal. Yup, true. To do so, you can manually set the bird's constructor, which is the bird constructor here. Yep, this part here. Set bird constructor property to the bird's object. Alright, let's learn how to do that. So bird prototype dot constructor is equal to bird. Okay, so this is how you set the bird's constructor property to the bird's object itself. Now it would display the function bird for the constructor. Alright, fix the code so the dog.constructor and beagle.constructor returns respective constructors. Right, guys, so we need so at the moment bird prototype is taking the animal constructor because of these lines, so it's inheriting from animal prototype from this one. What we have to do is give the bird constructor the bird prototype, the bird prototype, and assign it the bird constructor and assign it to the bird's prototype, and then the dog constructor and then assign it to the dog prototype. So how we're gonna do this is by taking the object, say the prototype's constructor, prototype dot constructor, bird prototype constructor, and we're going to be assigning it to the bird. Alright, similarly the dog one as well, prototype constructor, and assign it to the dog. So now what we should get is the dog constructor should return a bird. Let's have a look if it does. I'll just console.log it. Dog constructor. Alright, here we go. Yep, takes it returns the bird, and the beagle, which is a dog, it should return the dog. I'll just console.log as well, that as well. Here we go. Perfect. And or obviously the other way you could do this is also in this way. So just I'll put this way as well in the comments if you guys want to use this too. They're both right. Okay, do that one, and then this as well, bird, dog, and then this one goes to bird, and this one goes to dog. Oops, dog. I was supposed to do dog. Perfect. All right. This should also work. Let's have a look if it does. Just to ensure that we are doing it properly. No, it doesn't. I was wrong. Yep, so forget this one, guys, and just use this this way here. Alright, hope you guys learned a lot from today's video session as well, and it was really helpful for you. Again, if you guys have any questions, please leave a comment in the video, and I'll reply to you guys as soon as possible. Alright, until then, go and practice coding.